Chapter 8 starts going over quadratic functions. Quadratic functions are functions that are drawn on a coordinate plane that look like a U. In 8.1, we are working with quadratic functions in the form of ax squared. With these quadratic functions, they are drawn on a coordinate plane. They look like a U. That U is called a parabola. The parabola can either open up or open down. I'm going to tell you a lot of information right now. I don't expect you to write it all down. Just listen for right now. We're going to get into some examples where you're identifying these things. But like I said, I'm going to explain it to you now so that way you're a little bit more aware of it before just jumping into it. So that parabola opens up or opens down. If that parabola opens up, you have something called a minimum value. That minimum is the lowest point on that parabola. If that parabola opens down, you have a highest point, which means you have a maximum. That point that I'm talking about, that's either your minimum or your maximum, is called your vertex. That vertex is either the highest point of the parabola or the lowest point of the parabola where the two sides meet. That vertex has something that is invisible that goes through it called an axis of symmetry. That axis of symmetry is just an invisible line that cuts the parabola in half. If we look at this parabola, for example 1, we're looking at a couple of different things within it. We have the domain, we have the range, we have the vertex, the axis of symmetry, your x-intercept or intercepts, your y-intercept, or your y-intercepts, and whether or not it opens up or down, and you have a maximum or a minimum. With the domain, your domain are your x values that are covered. Automatically, with any of these parabolas, your domain is all real numbers. So you can just write the all real numbers symbol. Your range will be represented using an inequality. It will always deal with your y values that are being covered. So your domain is always your x values that are being covered by the line that's on that graph. Your range is always the y values that are being covered by that line that's on that graph. For here, you have a y, always y when you're dealing with range. That parabola opens up. So because that parabola opens up, the lowest y value that you have there is -2. So y has to be greater than or equal to -2. So you'll realize with your ranges for these parabola, it's either going to be y is greater than or equal to a number or y is less than or equal to a number. If you have a minimum value like you do here, and that parabola opens up, it's going to be y is greater than or equal to a number for your range. If your parabola opens down, then you're going to have the highest y value that's part of that vertex. So your y is going to be less than or equal to a number for your range. Your vertex is the middle point, that is the lowest or the highest point that you see. With this parabola, that vertex is that -1, -2. Your axis of symmetry is found by taking the x value of your vertex and setting it equal to x. So in this case, we have x is equal to -1. Your x-intercepts and your y-intercepts. Remember, your x-intercepts are where that line crosses the x-axis. We have something here. We have one here. Your first is at -2 1/2. So that's going to be the ordered pair -2.5, 0. Your second is at 0.5. So that's 0.5, 0. So you have two x-intercepts here. Most of the time with your parabolas, if it goes through the x-axis, you're going to have two, unless the vertex is on the x-axis. With your y-intercepts, you only have one here, and that y-intercept is down here at 0, -1. This parabola opens up, so you have a minimum value. You can just write min with that as well, or circle minimum. Example 2, Our domain of this parabola, again, automatically all real numbers. Our range, our lowest value is that -3 on the y. So then it goes up, so y is going to be greater than or equal to -3. Our vertex is the ordered pair, that is our lowest ordered pair here, so that's going to be 2, -3. The axis of symmetry is always x is equal to the x value in your vertex. So that's going to be x is equal to 2. You have x-intercepts here and here. So we can estimate them to be 0.25, 0, and 3.75, 0. Again, we just estimate them. Your y-intercept is at 0, 1. This parabola opens up, so we have a minimum value. For example, see this parabola for our domain. Again, automatically, all real numbers. Our range, we have a highest value here at y is less than or equal to 7. Our vertex is the ordered pair -3, 7. Our axis of symmetry, remember x is equal to, and then the x value from our vertex. So x is equal to -3. Your y-intercepts, we're just going to estimate these. We're going to have -5, let's do -5.75, 0, and -0.25, 0. Your y-intercept, you don't see one here. It will go through the y-axis eventually, so we're not going to worry about that one for right now. It's not none because it will cross over that y-axis. We're just not going to worry about putting that down because we don't know exactly where it goes through the y-axis. This parabola opens down, so we have a maximum value. With the next part of this lesson, we are going to be graphing these parabolas. With them, you will need to draw yourself or make yourself a function table to make your life a little easier. In example A, we are given f of x is equal to 2x squared. If we plug in the values of x that are given for us, we're going to have 2 times -2 squared, 2 times -1 squared, 2 times 0 squared, 2 times 1 squared, and 2 times 2 squared. -2 squared is 4. 4 times 2 is 8. That gives us the ordered pair -2, 8. -1 squared is 1 times 2 is 2, so that's the ordered pair -1, 2. For 0 squared, that's 0 times 2 is 0, so that's 0, 0. 1 squared is 1 times 2 is 2, so that's 1, 2. And then 2 squared is 4 times 2 is 8, so that's 2, 8. To graph these ordered pairs on the coordinate plane, -2, 8 is here, the -1, 2 is here, then we have 0, 0, and everything mirrors what we already wrote down. So from here, we're going to draw this parabola to go through these ordered pairs, and we draw those arrows at the tops of each of these sides. If we want to state the domain of this, we're going to have all real numbers. The range is y is greater than or equal to 0. For example B, we are given g of x is equal to 5x squared with x values of -2, -1, 0, 1, and 2. So we are going to have 5 times -2 squared, 5 times -1 squared, 5 times 0 squared, 5 times 1 squared, and 5 times 2 squared. So the -2 squared is 4 times 5 is 20, so it's -220. The negative 1 squared is 1 times 5 is 5. So that's negative 1, 5. Then 0 squared times anything is 0. So that's 0, 0. The 1 squared is 1 times 5 is 5. So again, we have 1, 5. And then that 2 in there is going to give us 20 again. So that's 2, 20. To graph these ordered pairs, we cannot graph the negative 2, 20 on this coordinate plane that's given to us. So we're going to graph the negative 1, 5, which is here, which also means we're going to have a 1, 5 because our vertex is at 0, 0. So this is going to be really, really narrow. And it's going to look similar to this. So again, if we write our domain, automatically, all real numbers, range, y is greater than or equal to 0. For example C, we have p of x is equal to negative 3x squared. So again, we're going to use the negative 2, negative 1, 0, 1, and 2. For the negative 2, plugging it in, we have negative 3 times negative 2 squared. Then we have negative 3 times negative 1 squared. Negative 3 times 0 squared. Negative 3 times 1 squared, negative 3 times 2 squared. The negative 2 squared is 4 times negative 3 is negative 12. Negative 1 squared is 1 times negative 3 is negative 3. 0 squared is 0 times negative 3 is 0. The 1 squared is 1 times negative 3 is negative 3. And we get negative 12 for the bottom as well. So these are giving us ordered pairs of negative 2, negative 12, negative 1, negative 3, 0, 0, 1, negative 3, and 2, negative 12. So negative 2, negative 12 is here. Then we have 1, negative 3, negative 1, negative 3, I'm sorry, it's here. 0, 0, 1, negative 3, and 2, negative 12. So we're going to go through these ordered pairs, draw the arrows, state the domain and range. Your domain, again, automatically are real numbers. Your range is y is less than or equal to 0. For our next example, we have h of x is equal to negative 1/3 x squared. You'll see with the rest of the ones that we're going to be doing in this part, all of these have a fraction that is your a. So the number that's being raised to or multiplied by the x to the power of 2. Now, when I choose x values with these, I take into consideration my denominator. So if you see here with example A, my denominator is 3. So I want to choose numbers that's going to make my life a little easier when I multiply this fraction by whatever I'm going to get. I wouldn't choose like negative 2, square it, I get 4, and have to multiply 4 by 1/3. That would leave me with a fraction, and that's a lot harder to graph on the coordinate plane. So I choose not to work with those. For these, we have negative 9, 3, 0, 3, and 9 for our x values. If you wanted to use negative 6 and positive 6 as well, you can do that also. It's totally up to you. It's definitely going to work. So let's do that. Let's do negative 6 and positive 6, so that way we're not working with such larger numbers. So if we plug in the negative 6, we're going to have negative 1/3 times negative 6 squared. We also have negative 1/3 times negative 3 squared. Negative 1/3 times 0 squared. Negative 1/3 times 3 squared. Negative 1/3 times 6 squared. The 6 squared and the negative 6 squared are 36. If we take the 36 and divide it by negative 3, it gives us negative 12. So that's going to be negative 6, negative 12. For the 3 squared and the negative 3 squared, we're going to have 9. So 9 times negative 1/3 is negative 3. So that is negative 3, negative 3. And we're going to do the same thing, positive 3, negative 3. And then if we plug in the 0, 0 times anything is 0, so that's 0, 0. To graph these, we have negative 6, negative 12. So that's this ordered pair here. Negative 3, negative 3. 0, 0, 3, negative 3, and 6, negative 12. So again, we just draw our line through these ordered pairs, making sure we have arrows, and then state the domain and range. Our domain, automatically, all real numbers. Our range is opening down, so y is less than or equal to 0. For example, 3b, we're given f of x is equal to 1/3 x squared. Again, I'm going to change that negative 9 and that positive 9 to negative 6 and positive 6, just so that way I'm working with easier numbers. I'm going to have 1/3 times negative 6 squared, 1/3 times negative 3 squared, 1/3 times 0 squared, 1/3 times 3 squared, and 1/3 times 6 squared. You'll see with the last one that we did that I can literally do the first 3, realize that the opposites of the negative 6 and the negative 3 are going to give me the same solution, so I can just rewrite those. So negative 6 squared is 36. 36 divided by 3 is 12. So that's negative 612. My positive 6 is going to give me the same thing, so that's going to be positive 612. The negative 3 in for x, I get 9. 9 divided by 3 is 3, so that gives us negative 3, 3, and positive 3, 3. Then we also have the 0. Anything times 0 is 0, so that's 0, 0. So for this one, we're going to go up instead of going down. So we're going to go negative 6, 12 is here, negative 3, 3 is here, 0, 0, 3, 3, and 6, 12. And then we just draw the line going up. State the domain and range. Your domain is all real numbers. Your range, your y values are going up. So y is greater than or equal to 0. For example, C, we're given n of x is equal to 1/2 x squared. We see that our denominator in that fraction is 2, so I want multiples of 2 that I'm going to plug in for x. If I plug in a negative 4, a negative 2, 0, 2, and 4, we're going to have 1/2 times negative 4 squared, 1/2 times negative 2 squared, 1/2 times 0 squared, 1/2 times 2 squared, and 1/2 times 4 squared. The 4 squared is 16. 16 divided by 2 is 8. The 2 squared and the negative 2 squared is 4. 4 divided by 2 is 2. And then 0 squared is 0 times 1/2 is 0. So this gives us negative 4, 8, negative 2, 2, 0, 0, 2, 2, and 4, 8. So plotting these ordered pairs, negative 4, 8 is here. Then we have negative 2, 2, 0, 0, positive 2, 2, and positive 4, 8. Our domain for this one is all real numbers, and our range is y is greater than or equal to 0. For example, D, we are given a decimal. With this decimal, you have negative 0.1. It is probably easiest for you to turn this decimal into a fraction. The negative 0.1 as a fraction, that 1 is in the tenths place, so that's negative 1 over 10. Again, it probably is going to be easier for you in order to use the fraction. For me, I would use the fraction because to me, fractions are easier than decimals, especially with multiplying. For your x values, you're given negative 10, negative 5, 0, 5, and 10. We have g of x is equal to negative 0.1 x squared. So this is going to be the same thing as saying negative 1 over 10 times negative 10 squared. negative 1 over 10 times negative 5 squared, negative 1 over 10 times 0 squared, negative 1 over 10 times 5 squared, and negative 1 over 10 times 10 squared. The 10 squared and the negative 10 squared is 100. 100 divided by negative 10 is negative 10. The negative 5 squared is 25. If we divide that by negative 10, we have negative 2.5. 0 squared is 0, times anything is 0. So we're going to have negative 10, negative 10, negative 5, negative 2.5, 0, 0, 5, negative 2.5, and 10, negative 10. So plotting these points, negative 10 is here. The positive 10 is here. Negative 5, negative 2.5 is here. Positive 5, 2.5 is here. And 0, 0 is here. Our domain for this one, like the rest, are all real numbers. Our range, it opens down, so y is less than or equal to 0. For example, E, we have h of x is equal to negative 1/4 x squared. We are given negative 8, negative 4, 0, 4, and 8. With this one, I'm also going to do negative 2 and positive 2, because we can use those as well. So negative 8, we plug in, we have negative 1/4 times negative 8 squared. That negative 8 squared is 64, divided by negative 4 is negative 16. So that's negative 8, negative 16. We can do the same thing for the positive 8. For the negative 4, we're going to have negative 1/4 times negative 4 squared, which is 16, divided by negative 4 is negative 4. So that's negative 4, negative 4. We're going to have positive 4, negative 4 as well. For the 2, that's negative 1/4 times negative 2 squared. Negative 2 squared is 4, divided by negative 4 is negative 1. So that's negative 2, negative 1, and positive 2, negative 1. And then we have 0, which is going to give us 0, so that's 0, 0. So the 8, negative 16, and that negative 8, negative 16 are not going to be able to be drawn on this coordinate plane. However, the negative 4 can, and it's going to be here. Then we have negative 2, negative 1, 0, 0, 2, negative 1, and 4, negative 4. So we draw those lines through those points. Our domain is all real numbers. Our range is y is less than or equal to 0. For our last question, it tells us the diagram at the left shows the cross-section of a satellite dish where x and y are measured in meters. Find the width and the depth of the dish. Your width is from side to side. So if you're going from negative 2 to positive 2, that's 1, 2, 3, 4 meters. So your width is 4 meters. Your depth is from the top of this, oops, not there, the top here to the bottom of it. So that's up 1, your height or your depth is 1 meter.